The next slide depicts patterns of activity and changing. If you observe this lower right-hand four-cell table, you'll see the distribution of cases that ended up in the cell they started out in. So as you can see, the standard unmanaged folks tended to stay where they were. They stayed put, whereas fewer of these stayed in their cell that they started out in. By the way, they didn't know that there were these other cells in the study. All right, and you can see now that the time of use cases and the managed cases were the ones that tended to either change their charging scenario permanently or to experiment with other statuses. So these are the people who changed from unmanaged to managed or managed to unmanaged or tried various things out. This case up here on the upper left is the Christmas tree light case. So we found 7 types of behaviors that households engaged in to manage their charging. And this figure categorizes those. Okay, let's look at the kinds of behaviors across the bottom here. First, they set for unmanaged, either permanently or temporarily. They set around time of use hours, so they went in and set up their plug to come on at 8 o'clock at night and stay on until 2 o'clock the next day. That enabled them to charge during the day, part of the time. Or they set it for overnight hours, something like midnight to 5 or 10 to 6 or something of that nature, permanently or temporarily. They left the programming as it was. They said, forget about it, it's too much trouble. They self-managed, or they wanted to change to unmanaged, but they stayed managed because they thought it would help the study. On the right side, going down, you can see each of the permutations and combinations of pricing and charging. And without going through all those, let's look at the blue one at the top, time of use cases who started out managed and ended up managed. And you can see they tended to set around time of use hours or overnight, or they left their programming as it was, or said they forgot about it, or were conscientious. Let's look at the people who started out in managed as standard cases. You can see they're all over here in the unmanaged category. Okay, so people loved to drive on electricity, and what most people didn't appear to figure out, only a handful did, was that it cost significantly less to charge their vehicles, even at time of use rates, than it did to buy gasoline. So these figures came from Xcel Energy. And what I just want to show you is that under the time of use summer on-peak rates here, this 93 cents, it's actually almost $1 cheaper per gallon to drive even on time of use on-peak rates. We can return to this point later. And now I'm going to turn this over to Professor Maximovich.
I should say I teach classes at the University of Colorado. Mainly in the area of power electronics. This fall semester I'm teaching a class on power electronics for electric drivetrains. It's a brand new class. I'm even now thinking about what exactly I'm going to teach about tomorrow. But it feels somewhat similar to here. The room here is a lot nicer than my classroom, but I have about 50 super enthusiastic students about electric drivetrains. They want to learn how to engineer them, and that's about the same as what we have here. There I have 20-year-olds, and here 20-year-olds as well. So as Barbara mentioned, this part of the talk is going to be about the data collected from 2 different sources. One source is from the vehicle, from the loggers that were installed on the vehicles, and the other one is from logging the data from the smart plugs. So we will see how, what the actual data is collected for real. This is real driving under real conditions over a significant period of time. And we will specifically look at the driving patterns, the charging patterns that emerge from the data, and in the end we have a brief comparison between the 2 groups, the managed and unmanaged group. All right, so there were a total of 27 vehicles in Boulder, 138 households. The smart plug data collected vehicle electricity use, and from the vehicle loggers we had a number of channels of data available, some of which are represented in the data that I will show, or the analysis that I will show here, and some have not been analyzed yet. So there's quite a bit of work to be done yet on the data set that we have available here. So again, it's a significant data set, around 12,000 vehicle trips, a total of more than 90,000 miles, and about 27 megawatt hours of electricity used. It's hard to put these numbers into perspective, so we'll of course look into a more meaningful representation of what these numbers really mean. So here's a chart that to give you an idea of what is the type of data that we actually have had access to. So the top chart right here shows the vehicle speed as a function of time. The time here is shown in hours. So this is just a very, very small sample for one particular vehicle, right? So one particular example just to give you an idea of how the data actually looks like. And what you can see here is that over this period of time from about 2 p.m. to 8 p.m., this particular vehicle made 1, 2, 3, 4 trips. And those trips are actually very short. There's a 5.2 mile trip, followed by an exceptionally short trip, 0.2 miles, nothing, right? It's just moving probably from the garage to outside. 1.2 mile trip, followed by 1.9 mile trip. And this is the type of data, it's a one channel of data coming from the vehicle logger. The time resolution of the data from the vehicle logger is also exceptionally high. It's a second-by-second data, right? This gives me an opportunity to also define what we mean by trip, just to avoid confusion, because you may think of a trip going from home to going around to take your kids to school and then going to work as one trip. The way we define trip here is the time that the vehicle is actually on, and the trip ends when the vehicle is off for at least 15 minutes. All right, so the pause that we use to define the single trip is a 15-minute idle time with the vehicle completely off, right? So that's a definition of what trip means. It is an important definition because you will see later on, at least for the city of Boulder environment, many trips are actually very short, as this example actually shows right here. Okay, so the top, again, is coming from the vehicle data logger, just one channel represented. There are 100 of channels of data coming in. The second graph here is coming from the smart plug data logger, right? So this is a complement to the vehicle logger. The smart plug data logger is actually recording when electricity is consumed from that particular plug. In this particular study, there were no, all charging was done at what is called level 1, right? So it's a standard 120 volt, 15 amp circuit. And so the charging power is in the order of 1.3 to so kilowatts. And it's flat over a charging period. It takes a total of about 3 hours to fully charge a fully depleted battery. So 3 hours is the charging time for the battery that is included on this plug-in vehicles. So you see that in this particular example, this vehicle had actually, over this period of time, 2 charging events, one which was worth 2.7 kilowatt hours, and the second one that was worth 2.1 kilowatt hours. All right, and then finally, what we can do now is we have these data sets that are coming from 2 different sources. We were able to actually put them together into one collective data set that can give additional information about, for example, state of charge of the battery system. How high is the battery charged? And so that's an example of that is shown as a bottom plot right here. The scale is from 0 to 100%. And I should warn here you that this 0 to 100% is normalized to the EV range. It is not 0 to 100% of the entire battery pack. It's just 0 to 100% of the EV range of the battery. And so you can see what happens here. So the vehicle at this point here, was in the hybrid mode. You know, it did not have enough charge to actually support EV mode of operation. It was in a hybrid mode right here. Upon this charging event, the state of charge of the battery increased up to, you know, about 80%, and then it stayed flat because there was nothing going on right here. And then another 2 trips brought that state of charge down to about 50%, followed by another charging event that brought the state of charge up to about 100%. So it's a fully charged, you know, fully EV-ready vehicle with a full EV range of about 13 to 14 miles. So that's the data set we have available. So just give you an example of that. When I teach a class, I ask students to ask questions during the talk. So I'm going to ask you to do that just as well. If you have any particular questions that comes up immediately when we show the data, just raise your hand and we can do that immediately. Yes.
Did this study allow participants to level 1 or level 2 charge anywhere else, and did they?
Right. So we will talk more about where people charge. They could have charged anywhere they like. Right now, at homes, we know that they did not have any level 2 charging available. So charging at homes was done at level 1. Whether any charging done outside of home was anything else, we don't know exactly. But I would suspect very, very few of those events would have been included.